Dear colleagues, it's my pleasure to present our study towards information technology for BPMN models quality assessment based on intelligence theory. Let's begin with the agenda. I will present the introduction for this study, state of the art in the field, related work, overview, formal problem statement. Inside the Materials and Methods chapter, I will present functional model of the intelligent information technology, business process modeling rules, comparator network proposed for incorrect BPMN elements identification, and business process element weights and the approach to obtain these weights. As part of the results and discussion, I will reveal software implementation details, present BPMN models quality assessment results, and outline sample BPMN model analysis results. In the end, I will present conclusion and future work in this direction. Let's begin with the introduction. It's well known that effective internal workflow management is extremely vital for organizational competitiveness. A business process is a sequence of coordinated activities, events, and decision-making points. Graphical modeling helps to understand, analyze, and improve organizational workflows. This is the key tool of business process management or BPM methodology, which integrates management and information technology to enhance workflows. BPMN, or Business Process Model and Notation, is a key standard for documenting business process. BPMN ensures clarity for both technical and non-technical stakeholders, while business process modeling in general improves communication, product or service quality, and organizational efficiency. It's the main idea that business process models should be of high quality. Therefore, the research object of this study includes the procedure for assessing the quality of business process models. The research subject includes intelligent IT for evaluating BPMN models quality. And the goal of this paper is to enhance BPMN models quality and prevent workflow errors due to structural issues. There are many different notations for business process modeling exist, such as BPMN, EPC, which stands for Event-Driven Process Chain, IDEF family of notations, and DFD or data flow diagrams. They all help to visualize and analyze workflows from different perspectives. However, BPMN has become the leading standard in the industry exactly because of its flexibility, clarity, and broad support of different tools and organizations. BPMN provides intuitive graphical representation of business logic for different range of stakeholders. Its core elements are demonstrated here, and they include events, activities, gateways of different logic, and control flows. Gateways support branching and conditional flows, as well as process loops and other more complex structures. BPMN also uses pools and lanes to clearly define roles and responsibilities in collaborative business process. This notation is suitable for both simple documentation and complex automation purposes. It is widely used in business process management systems, or BPMS, for accurate and transparent modeling and automation of the workflows. So it's clear that business process modeling helps to bridge the gap between business and IT through visual representation. It also enhances workflow transparency thanks to BPMN notation, monitoring, and performance assessment of the organizational activities. The main statement is that models quality is essential for the success of business process management initiatives. Different studies consider use of structural metrics to quantify size, complexity, and control logic of BPMN models. They also consider qualitative aspects like understandability and maintainability that affect usability and adaptability of workflow models. They also consider evaluation methods that include user surveys or software engineering-based metrics. Different studies also consider the use of modeling rules and guidelines to ensure both syntactic and semantic correctness of business process models. They consider different structural attributes that can reveal models' efficiency, and additionally define thresholds for metrics using data mining and expert recommendations. As for the problem statement, we consider the extraction of BPMN elements features by processing BPMN model files as specially organized XML documents. Then we propose to identify incorrect BPMN elements to describe business process models as binary vectors. And finally, to apply the quality assessment model, which consists of the weighted sum equation demonstrated here on the slide. The general schema of the proposed approach is demonstrated here in the right side of this slide. Functional model of the intelligent information technology proposed consists of the four main activities. They include processing of BPMN model files, extraction of BPMN elements features, identification of incorrect BPMN elements, and finally assessment of BPMN models quality. As for the business process modeling rules, we consider there are 6 rules. First rule says start events should have one outgoing flow. Second rule states that intermediate events should have one incoming and one outgoing flow. Third rule says that boundary events should have one outgoing flow. Rule number 4 says that end events should have one incoming flow. Fifth rule says that activities, both tasks or sub-process, should have one incoming and one outgoing flow. And the last but not the least, rule number 6 says that gateways should have either one incoming and two outgoing flows, being splits structures, or two incoming and one outgoing flow, being join structures. The formal expressions used to validate business process model elements towards these rules are demonstrated in the table here. So, based on these rules and the input data, we propose the comparator network for incorrect BPMN elements identification. This structure is based on the intelligence theory and predicate logic to formalize human-like reasoning. It's designed as a connectionist system inspired by artificial neural network structures, and it's used to identify incorrect BPMN elements by comparing model properties to expected rules. It employs indicator functions to evaluate incoming and outgoing degrees for each element, and it enables automated assessment of BPMN logic's consistency based on the modeling guidelines. It also enhances machine-based reasoning compared to classical comparator identification methods. The weights of each BPMN element is expected to demonstrate how it's important for the model's correctness, and it's calculated by dividing the total impact of all elements demonstrated here in the table of the same type by their number in a BPMN model. The developed software is created using Python and standard libraries for XML files data processing. It reads BPMN model files from the file system using the OS package, parses BPMN files as XML documents using the XML package, analyzes model structure and logic to assess quality based on predefined metrics and rules, calculates element weights, and applies the proposed comparator network for validation, and stores quality assessment results in CSV format suitable for easy analysis and reporting. The obtained business process model and quality assessment results are demonstrated here. We have tested the solution on 3,729 BPMN models from open source Camunda GitHub repository. 3,722 models were successfully processed by the software, while 7 models were failed due to the improper XML markup. The quality score calculated is ranged from 0.49 to 1, and 25% or 918 models belong to the first quartile, demonstrating quality between 0.49 and 0.94. 17% of models, or 639, had quality measure between 0.94 and 0.96 and belong to the second quartile. 33% of models, or 1,227, had quality measure between 0.96 and 0.99 and belong to the third quartile. And only 4%, or 162 models, had quality between 0.99 and 1, being perfect models, basically, and belong to the fourth quartile. As can be seen, this distribution is demonstrated using the pie chart and also the table presented in the bottom of the slide. We have used sample BPMN model to demonstrate the analysis results. We analyzed model that describes goods dispatch business process in a small hardware store. 6 incorrect elements were detected using the proposed intelligent technology. First, marked as E1, states that parallel gateway with 1 incoming and 3 outgoing flows detected, which increases process complexity. E2 says that task named choose offer has no incoming flows and it's the missing start event. E3 says that parallel gateway with 1 incoming and no outgoing flows is present, which lacks the logic after the gateway. E4 stands for the intermediate event named insurance required, as the question is used incorrectly. It should be a boundary event. And E5 says that task named make offer has no ongoing flows. It's the missing end event signal. And E6 says that task package goods has 2 incoming flows, but it should be used here a join gateway, not a task. And for the conclusion and future work, in this paper, we address the problem of quality analysis and improvement for BPMN-based process models. BPMN is a key for bridging IT and business, and this is why high-quality models are essential to avoid any errors or other drawbacks. The proposed technology is based on intelligent theory. It includes extraction of BPMN elements from XML files, identification of incorrect elements, and quality assessment through the weighted sum of elements evaluations and type-specific impacts. The experimental results demonstrated in the data set that 97% of models had very high quality, bigger than 0.79. And example model illustrated detection of typical modeling errors still presented in the practice of BPMN modeling. The future work includes applying machine learning to predict BPMN models' quality, the use of fuzzy logic to handle uncertainty in modeling rules, deep analysis of syntax, semantics, and collaborative process, and using size and complexity constraints to optimize models in terms of their volume. Thank you very much for your attention, and I will be glad to answer all the questions.